So we're going to move on to our next type of data, and this data is thankfully a little less grisly. It's talking about the time it takes to have a clinical trial published. So as we mentioned earlier, this is, while survival analysis is often used in biostatistics literature for actual survival time, that's why the term survival is in the title. It's a general use purpose for timed data. And so here we're going to use data that's not actual survival, just how long it takes to get a paper published. Okay, so one of the features we're going to look at on a categorical variable is this pos-res feature. That stands for positive result. So when whether the clinical trial finished with a positive result, maybe for a treatment, or a negative result for a treatment, or it depends on what they're studying.
The trial was successful, right? The trial was set out to
establish
something.
Yes, yeah.
And either it did or it didn't. Yeah.
Yes. Okay, so let's take a look at these. So we have result equals 0, that's a negative result, and result equals 1 is a positive result. So we can see that negative results, some of them just never get published, and that's kind of well known in the scientific literature that it's hard to publish a negative result because, well.
So in this example, a high hazard is good because it's the time to the event, which is publication. So
yes, yeah. Okay. Again, we can fit a Cox model. If we want to do a log rank test or something close to it, we could do it with the Cox model. So this is very similar to what we saw before, looking at sex for the different survival in the cancer data.
So that p-value is not significant, and you can sort of see from the plot that that even though it looks like there's a bit of separation, the standard errors are quite wide, and
and for this region here, there's not much of a difference.
Much difference, right?
Yeah. So if we had come up with a hypothesis that there's a difference in this period, we might have had a significant p-value. But the log rank test looks at the entire survival curve. Okay. Okay. So now we're going to include some of the other features. So we're going to drop this MEC is the funding mechanism used. I guess that's whether it's NIH or privately funded or NSF, and fit a Cox model. And then, okay, so now let's see.
Oh, there's some significant things there, Jonathan.
Yeah, pos-res becomes significant now. Impact, so this is some measure of the I guess this is post hoc. Once the paper is published, you can measure its impact. And studies that were published relatively quickly, and some are associated with having high impact. That's what we can glean from this one. And similarly, now the effect for positive result is stronger. The p-value is smaller.
So that's interesting. That happens sometimes. When you look at a variable just on its own, it might be not significant, because there's other things going on, confounding factors that interfere with the variable. And now when you put in all these variables, pos-res now looks significant.
Yes, yeah. Like in a linear regression context, allowing for these other variables can reduce the extra variation, and then the difference can appear more significant. Right. Okay. And
so there's a third example, which is on call center data, and this is simulated data. And the analysis is very similar to what we've done, and so we'll leave that one for you.
Yes, we'll just note that the one new thing that in this call center data you'll see is that there's a multivariate log rank test, and that's, you can work by analogy with the log rank test is used when you have a categorical variable with 2 levels. Here we have some categorical variables with 3 levels, and for that, instead of the 2x2 table of the log ranks, there would be a 2x3 or a 3x2 table, and that's the multivariate log rank test. But the interpretation is quite similar, so we'll leave that for you to do offline.